discuss our training, test, and validation sets in machine learning. What is cross validation and how does it differ from a simple train validation test split? So, about training set, this is an actual data set from which a model trains, which means the model sees and learns from the data and predict the outcome to make the right decisions. Most of the training data is collected from several resources, then pre-processed and organized to provide proper performance for the model. This data is more than 60% of the total data available for the project. Most of the training of this data is collected from several resources and pre-processed and which are pre-processed and it organizes and provide the proper performance of the model. So this data is more than 60% of the total data variable of the project. About testing set, this data set is independent of the training set but has a somewhat similar type of probability distribution of classes and used as benchmark to evaluate the model. Used only after the training of model is complete. So it is used after the training of the model is complete, and it is a somewhat similar type of probability distribution of classes which are used to use as benchmark to evaluate the models. Testing set is usually properly organized data set having all kind of data for scenarios that model would probably be facing when used in the real world. So it contains the scenarios of the models which works in the real world or the scenarios of the real world. The data is approximately 20 to 25% of the total data available on the project. About validation set, the validation set is used to fine-tune the hyperparameters of the model and is considered a part of training of the model. The model only sees the data for evaluation but does not learn from this data, providing an objective, unbiased evaluation of the model. Validation dataset can be utilized for regression as well as by interrupting training of models. When loss of validation datasets becomes greater than loss of training datasets, which means reducing bias and variance. This data is approximately 10 to 15% of the total data value. So let's move on to the cross validation machine learning. So is a technique used to check how well a machine learning model performs on unseen data while preventing overfitting, and it works by splitting the data set into several parts, training the models on some part and testing it on the remaining part. Repeating this resampling process multiple times by choosing different parts of the data sets and averaging the results from each validation steps to get the final performance. The types of cross validations are there are several types of cross validation techniques which are as follows. First is holder validations. In a holder validation method, typically 50% data is used for the training and 50% is used for the testing. So making it simple and quick to apply, the major drawback of this method is that only 50% data is used for training. The model may miss important patterns in the other half, which leads to high bias. The second is LOOCV, leave one out cross validation. Leave one out cross validation. In this method, the model is trained on the entire dataset except for one dataset point which is used for testing. This process is repeated for each data point in the dataset. So all the points are used for training, resulting in low bias. And testing on a single data point can cause high variance, especially if the point is an outlier or it is outside of the data set. So, and also it can be very time consuming for large data set as it require more iteration per data points. And now moving on to the k-fold cross validation. The k-fold cross validation splits the dataset into k equals size folds. The model is trained on k minus 1 folds and test on the remaining folds. This process is repeated k times, each time using the different fold of testings. Now, let's see a difference table between train validation test speed and cross validation test speed. So now moving on to the difference table between train validation test split and cross validation. In this method and train validation test split, in this method the data set is divided only once. For example, 70% training and 15% validation and 15% testing. The model is trained on the training set and tuned using the validation set. The final result depends completely upon the one split. And in the cross validation, the data set is divided into k equal size folds equally, usually 5 or 10. The model is trained k times. Each time a different fold becomes the validation set and the remaining folds become the training set. So every data point gets a chance to be in a validation exactly once. And model training count. uh, the train validation test split, the model is trained only once. This makes the process fast, but the model gets only one chance to learn from the data. If that split is not representative, performance may be misleading. And in cross validation, the model is trained k times, once for every fold. This gives multiple performance results, and the final score is average across all folds. This improves reliability. The validation reliability in train validation test split, validation accuracy depends heavily on the single split. If the validation set is too easy or too difficult, performance may be overestimated or underestimated. And in cross validation, in k-fold cross validation, performance is average over multiple validation sets. This reduces randomness and gives a fair, stable estimate of how the model generalizes. Uh, the suitable data size for the train validation test split is like this works best for the large data set where even after splitting each set still has enough samples, but with small data sets results may be misleading. And in cross validation, this method is best for small or medium data sets because it makes maximum use of available data. The model trains on most of the data in each iteration. The computational cross, this method is computationally very cheap since training happens only once, ideal when speed matters or when dealing with heavy models. Cross validation, in this method, the computationally expensive because the model trains k times, times increases and larger values of k or more complex models use it when accuracy is more important than training time. Overfitting, the risk of the overfitting risk is lower because the model is tested on multiple validation sets. This gives a more realistic view of how performance on unseen data is trained. And the risk of overfitting is higher because of the model is tuned based on the single validation set and the train validation test. Also, the computational cost and the suitable data size we have already covered. So that's it, guys, for today. We have completed the train validation set and cross validation difference, and we have also seen the machine learning and train testing set and validation sets. That's all for the question number third. We have explained everything which was asked. Thank you so much. Let's in the next video, let's see the fourth question.